Assalamualaikum everyone. In this video we'll see what is type 2 partial fractions. Okay, in the previous video we saw what is type 1. Let's see what is type 2. Here the denominator g of x contains repeated linear factor ax plus b whole power n and non-repeated linear factor px plus q. In type 1 we only had simple which is not repeating, a simple linear factor which is not repeating, we had that. But here in type 2 we have a linear factor, but the extension here is it is repeating. Okay, and also it can have along with it a non-repeated linear factor. Okay, suppose the repeated linear factor is ax plus b whole power n, that means it is repeating n times, and this is a non-repeated linear factor, suppose px plus q. Okay, so how do we solve this? We in this type we are having in the denominator g of x we are having a repeated linear factor. Okay, we can have both of these, repeated and non-repeated linear fraction, or we can have only repeated. Okay, we can have both the cases. Now how to solve this? To every repeated linear factor, suppose the factor is ax plus b. Okay, the repeating factor is ax plus b and it is repeating for n times, suppose. So the corresponding partial fraction is taken as a1 by ax plus b plus a2 by ax plus b whole square plus a3 by ax plus b whole cube, so on till how many times? If it is repeating n times, so it will be an by ax plus b whole power n. If suppose it is repeating only twice, if the n is 2, so a partial fraction will be till here a1 by ax plus b plus a2 by ax square plus ax plus b whole square. Okay, यहाँ तक. If it is repeating 3 times, it will be till here. If it is repeating 4 times, it will have a4 by ax plus b whole power 4. Okay, I think this is clear. Now let's see an example. Suppose the question is 1 by x square into x plus 2. This is a proper fraction because the denominator is greater than the numerator, and also here x is a term which is repeating 2 times. Okay, so x square. Now this is a repeating factor, so it falls under type 2. As well as I have one more factor, that is x plus 1. It is linear. So this question falls under type 2. Okay. Now how to solve this? For this I'll be having 2 factors, and for this I'll be having only 1 factor because it is repeating 2 times. No, that's why I'll have 2 factors. Okay. So 1 by x square into x plus 1 is my given question. For this I'll be resolving it into 2 partial fractions. One is a by x, a constant over x, plus b by x square. It is repeating twice, no? So b by x square. If I would have x cube, so I'll be having here after b, I'll be having plus c by x cube. Okay, something like this. But in this case, I have only square. Next, the other factor is what? X plus 2. Yeah, x plus 2. So c by x plus 2, because it is simple factor, so c by x plus 2. I think this is clear. Let this be my equation 1. So step 2, what do we need to do? We need to take the LCM because we need to cancel out the denominators. So taking LCM, I'll get x square into x plus 2 as the LCM. X square and x plus 2 will be the LCM. Now a into x into x plus 2, because in the denominator of a I only have x. What I don't have, one more x I need and x plus 2 I need. I think you people know how to take out the LCM, so I'm not elaborating it. So after taking out the LCM, we'll be left with this equation plus b into x plus 2, because we already have x square in the denominator of b, right? So what I don't have is x plus 2. Now plus c by x plus 2. I have x plus 2 here, but I don't have x square. So c into x square. Okay. Now next, the denominators will be cancelled out. So what I'm left with, 1 is equal to a into x plus 2, a into x plus 2 plus b into x plus 2 plus b into x plus 2 plus c into x square. Okay. Now let this be my equation 2. Now what I need to do, I need to find the values of constants a, b and c. Okay. So here in the first case, if you see, here I've got 2 factors, right? One is x square and the other is x plus 2. So I'll equate the first factor to 0. I'm equating x to 0. I can equate x square also to 0. It will be 1 and the same. The square goes to the other side, becomes 0. X equal to 0. Okay. X square equal to 0 or x equal to 0 are nothing but 1 and the same. Okay. So I got the value of x as 0. Now what does this mean? I need to substitute 0 wherever I find x in equation 2. Okay, so here 1 is equal to a into x. What is x? 0. Then x plus 2 is nothing but 0 plus 2 plus b into x plus 2, 0 plus 2 plus c into x square plus c into 0 square. Now here 0 into anything becomes 0, right? Here as well, not here. Here 0 into anything is 0. This 0 into anything becomes 0. So this entire a term and this c term, okay, will be 0. Now I'm only left with what? B term. 0 plus 2 is nothing but 2. So 2 into b is 2b. So 1 is equal to 2b. 1 equal to 2b. Here 2 is being multiplied here. It is 2 into b. So this b goes to the other side, it divides. It's multiplying here, goes to the other side, it divides. So b is equal to 1 by, this 2 goes there, so 1 by 2. Now case 2. Case 2, I have another factor as x plus 2, right? So x plus 2, I am equating it to 0. So here this 2 is being added, goes to the other side, it subtracts. So x is equal to minus 2. Now that means what? The value of x is now what? Minus 2. So wherever I find x in equation 2, I am going to substitute minus 2 in place of it. So 1 is equal to a into what is x? Minus 2. Then what is x? Minus 2 plus 2. Minus 2 plus 2. Then again plus b into x minus x plus 2. So plus b into what is x? Minus 2. So minus 2 plus 2 plus c into x square. What is x here? I am having minus 2. So minus 2 whole square. So if you see here, this term minus 2 plus 2 is 0. This minus 2 plus 2 is nothing but 0. So 0 into anything becomes 0. So a and b terms are 0 now. I am only left with c. So minus 2 whole square will give you plus 4, right? Because 2 into 2 is 4 and minus into minus is what? Plus. So plus 4. So I get plus 4c. LHS as it is, that is 1. So 1 is equals to 4c. Here 4 is being multiplied. 4 into c. It goes on the other side, it divides. So it will be 1 by 4. So c is now what? 1 by 4. I got b value and I got c value. I need a. But I don't have any more factors here. So what I'll do? I'll go with the other method, that is comparing the coefficients. Okay. One method was equating. The other method of finding the values is comparing the coefficients. Now if you see here, in equation 2, the variable with the highest degree is what? Here if you see, if I multiply x into x, it will be x square, then plus 2x. This term is like this, and here it is x square. And moving on, do I have any term greater than x square? No. Even here I have x square. So I don't have any term which is greater than x square. So the greatest is what here now? X square. Okay. So now we'll compare the coefficient of x squares on both the sides. Okay. Case 3 is comparing coefficient of x square. You understood why I'm taking x square and why not x or why not x cube? अगर यहाँ पे मेरे पास x cube रहता था equation में, तो I would have taken x cube का coefficient. Okay. But for now I have x square as the greatest. So I'm going to take x square coefficient. Now here in equation 2, do I have any x square term on the LHS? No, I don't have it. So I'll be writing 0. Now here if you see, it is a into x square plus 2x, no? So I have an x square term here. What is the coefficient? A is the coefficient. So I'll be writing a. Then moving on, do I have any x square term? X square, here I have an x square term. So the coefficient is what? C. So plus c. Here now, c is adding here, goes to the other side, subtracts, right? So a will be equal to minus c. So a is nothing but minus c. I know the value of c, right? It is 1 by 4. So a is equals to minus as it is 1 by 4. Now I got 3 values, right? All the 3 values, one is a, the other is b, and the last is c. I got all the 3 values. Now the final step is to substitute all these values in our equation 1. So 1 by x square into x plus 2 is equal to, what is the a value we got? A is nothing but minus 1 by 4. So minus 1 by 4 by x plus b by x square. What is b value we got? 1 by 2. So 1 by 2 by x square plus c by x plus 2. What is the value of c? 1 by 4. So 1 by 4 by x plus 2. Now this minus 1 by 4 by x, I can write it like this, right? I can send this 4 to the denominator, right? Simply. So minus 1 by 4x plus 1 by 2x square plus 1 by 4 into x plus 2, right? I can write it this way. So this is my final answer. So this was the factor given to me. These are the partial fractions I decomposed it into. Okay, so that's it about this type 2. I think it is clear. Only the difference here is from type 1, or the only difference here is it is repeating. It can have a repeating factor and as well as it can have a non-repeating, whereas in type 1 we only had a non-repeating linear factor. Here I have a repeating as well as non-repeating. Okay, and I'll decompose the repeating ones in this way, and the non-repeating will be similar as type 1, same as type 1, not similar, same as type 1. Okay, so I think this is clear. If you have got any doubts, let me know in the comment section below which part you didn't understood. I'll try to explain you. Okay, so one thing I want to tell you here is, if you want to study partial fraction, you need to be thorough with the basics, okay, like LCM, finding LCM, and finding the factors, that is doing factorization, performing factorization, and you should know what is the degree, what is a coefficient, what is a quadratic equation, what is a linear equation, what is a polynomial. Okay, all these things you need to know in order for you to understand this partial fraction. So that's it for this video. Thank you.